Hi, everyone. Welcome back to Dave's Math Channel. I'm your host, David Tear, where I'm featuring a series. This is part two in a series on complex numbers. Today, I'm going to talk about complex addition and subtraction, which is actually pretty easy. I think it's going to be kind of a short video. So how do we add and subtract complex numbers? Well, it's pretty easy. All you do, you're given two complex numbers, and in the last video, I showed you that you can write any complex numbers in the form x plus I y, where x and y are real numbers, arbitrary real numbers. So if you're adding two complex numbers, your first one might be a plus ib, your second one c plus id. And the way you add these numbers, you just add the respective real and imaginary components. So since the real component of the first complex number is a and the second one c, you write a plus c, that's the real part, plus I times the imaginary part, which is b plus d. Those are both the terms that are multiplying I in the first equation. And similarly, subtraction is exactly the same, except instead of adding respective real and imaginary components, you're subtracting this time. So now you have a plus ib minus c plus id equals a minus c plus I times b minus d. Pretty easy. And you can also, I mean, here's just a couple examples. So, for instance, suppose you want to add 4 plus 2i and 6 plus 3i. You start by adding the real components, which are 4 and 6. That gives you 10. And then imaginary parts are 2 and 3. Yeah, those get 5. So the answer is 10 plus 5i. Similarly, for subtracting, 4 minus 6 gives you a negative 2. And 2 minus 3 gives you negative 1. So the answer is minus 2 minus I. That's all there is to that. So doing it algebraically is very easy, but it's also useful to do it geometrically. And you really should, like I mentioned in the last video, you should think of complex numbers as vectors in the complex plane. As far as addition and subtraction goes, they behave exactly like vectors. You probably learned how to add and subtract vectors when you were learning about, vector algebra. And this is really just 2D vector algebra. So for instance, suppose you wanted to add the vectors 3 plus 5i, that's the orange vector here, or the orange complex number, and you want to add that to set 4 minus 3i. Well, you can do that geometrically the same way you add vectors. You just join up the tail of the second vector to the head of the first vector, or these are really complex numbers, but you can think of them as vectors. And then when you do that, you get the sum, which you could also get algebraically, 7 plus 2i. So that's just the usual rule for adding vectors. And actually, there's two kind of rules you might have learned for adding vectors. The other one's called the parallelogram rule. If you don't want to move your second vector, you don't have to. You can just draw a parallelogram with your first vector, or your first complex number in this case, as one side, and then the second complex number. So here you have 2 plus 4i. You're adding that to 5 plus 3i, and you just draw them as vectors starting at the origin, but then you complete them with a parallelogram, and you look at the third vertex that's not at the origin. That happens to be 7 plus 7. So that's how to add two vectors using the parallelogram rule, and it still works for complex numbers. What about a geometric way to subtract two vectors? Well, that's pretty easy. I mean, all you really have to know is that subtracting two vectors is the same as adding the negative of the second one to the first. So here we have the two, I guess they draw them as vectors here. I mean, they write z1 and z2. That's the usual notation for complex numbers. But just z1 in more conventional notation is 4 plus 2i, and z2 is 1 plus 3i. So you want to negate z2 since that's your second complex number. If you do that, you get minus 1 minus 3i. And then you can use a parallelogram rule the same way as we did before. And if you do that, you'll find that the answer is 3 minus I. So that's basically all you need to know about adding or subtracting complex numbers. Just think of them as 2D vectors. Anyway, that's my talk for today. I hope you enjoyed it, and I'll see you next time.